was were written in two columns and you had to match, and one of them was Giger Marsden. And if you had not known about the exact names who performed this experiment, you would have actually not you would have been unable to solve the question otherwise, right? One was a photoelectric effect experiment, which was conducted by Hallwag and Leonard, not by Einstein, explained by Einstein. So again, another name, important name. One was Davison-Germer experiment, one was this experiment, and some other experiments as well. So somehow JEE Mains pays attention to the names of the scientists who performed the experiment, and it had been quite it had been seen quite few times, the same kind of thing, that exact names were used for the experiment. So this was conducted by Giger Marsden under guidance of Rutherford. What was this experiment? This was a thin gold foil on which this is a lead block and a source of alpha particles. So alpha particles were bombarded onto the gold foil, were projected onto the gold foil. So the observations, this was a circular zinc sulfide screen. Zinc sulfide has this property that when alpha particle hits zinc sulfide, the screen shows scintillation, the twinkling kind of effect. So if alpha particle strikes here, you would see a small twinkling here, small scintillation. So what was happening? Alpha particle, in this experiment they studied that actually most of the scintillations were like here. So which means most of the alpha particles passed straight away. Some were deflected by small angles, some by large angles, while some retraced their path. Very few retraced their path, 1 in millions basically, right? So this was the exact experiment, right? And from this, what Rutherford concluded. Now the conclusion were made by Rutherford. He said that this plum pudding kind of thing cannot work. The reason for that is, you can understand, if whole of the charge, positive charge is, if whole of the atom is a positively charged spheres, none of the alpha particle would actually pass through the gold foil easily, right? Getting the idea? That if this is a whole of the atom is a positively charged sphere, the alpha particle will not be able to pass through and it would be deflected. So most of the alpha particles would have been deflected, but it simply means that actually most of the atomic space is empty. That's why they passed undeviated, okay, undeflected. So some were deflected through small angles, means that actually there is a small positive charge and alpha particle approaching, traveling near the small positive charge is actually deflected, okay. Some were deflected through large angles, which means what? That actually this central positive charge is really massive, really heavy. It was heavy, that's why it could have sent the fast moving alpha particles away. It was really heavy, that's why it could have sent the the alpha particles away. Otherwise it would have started moving itself, right? And the last one, that very few retraced, right? Okay. Again a confirmation of the massive size, the heavy mass, sorry, massive, not size. Size is small, but very dense nature of the nuclei, right? So on this basis, he gave his model that actually there is a positively charged nucleus at the center, while the electrons revolve around it in circular orbits, okay. Okay, and what happens that when when this atom absorbs energy, the electrons excite to higher energy states. So these excite to higher energy state. Okay, and when the electrons release energy, they jump back to lower energy state, right? They jump back to lower energy state. Now, so shall we? Okay, shall we see further? So what happened actually then? Most of the things of Rutherford model were correct. It explained a lot of phenomena. It explained why when an electric discharge is passed through a gas, light is emitted. Because of the electric discharge, the electrons jump to higher energy state. When they come back, okay, when they come back, they release energy, okay, in the form of light. It was able to explain a lot of things, but then this theory came, Maxwell theory, which we studied already. Maxwell's electromagnetic wave theory. Okay, so what they actually what he actually said, as you remember, in Maxwell theory, that if a charge is accelerated, it releases energy. Okay, rather radiates, I should be using the word radiates energy in form of EM waves. Okay, this is the conclusion of Maxwell theory. We studied this. Then that when a charge was oscillating, then what happened? It radiated energy in the form of electromagnetic waves. The frequency of electromagnetic waves was equal to the frequency of the oscillating charge, right? Remember that? Frequency of wave was equal to frequency of the oscillations of charge, right? So here also, when electron, this is the nucleus, when electron was moving in a circle, okay, since circular motion is always accelerated, it was radiating EM waves. The frequency of these EM waves was equal to the frequency of circular motion. Okay, it was nothing but V upon 2 pi r. Remember, the time period is 2 pi r by V, right? So it was V upon 2 pi r. So in this manner, the charge was losing kinetic energy. It was slowing down, getting closer and closer and closer, and finally dropping into the nucleus. Okay, so this uninvited guest would actually have caused collapse of the nucleus, because nucleus has its identity because of the positive charge. If the electrons collapse into nucleus, okay, its identity is lost. It has no positive charge, so no nuclear properties, right? So Rutherford model failed to address this idea, right? And that's where Niels Bohr jumped in and he presented his own model. Is it okay? So I hope till now the picture is clear, right? So he used most of the good ideas, good things of Bohr model, combined a theory from here, a theory from there, and gave his model. We will discuss this. Can I erase this? Which charge particle? Yeah. Maxwell theory is a general theory. The charge particle can be positive or negative both. Here the charge particle in the model was electron. Okay? For example, if you apply Maxwell theory to lightning, lightning, bijli girna. When lightning happens, most of the time what happens? It's just a movement of ionized gas ions, atoms, ionized gas particles, I would say. Okay, the when they come in contact with the cloud, their electrons are pulled out. Because of high electric field, the electrons are pulled out. That's called field emission. We studied field emission. कुछ definition हमने पढ़ा था ना field emission का. Under electric field, we pull electrons. So that's what happening. That's what happens during lightning. That electrons are pulled out of gas atoms and they become ionized. These positively charged ions then move toward Earth, and they are heavy. They are large in size. They collide with others, and this collision produces energy. Also, because when they accelerate, they produce a lot of EM waves. So that's why visible light, because of collisions, radio waves, and all other type of waves of lower energy level, lower than light, are released, okay, while lightning. And that's why whenever there is lightning, your DTH connections are lost, radio signals are lost, because a hell lot of electromagnetic interference is there, right? So Maxwell theory is applicable to any scenario. Just think about sparking anywhere, Maxwell theory is working there. Okay, applicable. Can I erase this? So we studied Rutherford model as well. Okay. Rutherford model said a few things which I would tell you so that we can carry them forward. The Rutherford model said that electrons revolve around atom in circular orbits, and the electrostatic forces balance the centrifugal forces, or you may say that the electrostatic forces they provide the centripetal force. You remember centripetal force and centrifugal force are the two sides of a same coin. If you are viewing circular motion from rest, you will see centripetal. If you are a part of the circular motion, you are sitting on the circularly moving body, you would observe centrifugal force, a force that would try to pull you out, right? So they are faces of the same coin. So whenever I say one thing, I just mean the other thing as well in another frame, right? So this is one thing which Bohr said, just one thing. Now what else Bohr said? This is Bohr's model. I'll discuss small background. Just before the Bohr model, Planck's theory came. Okay, Planck's theory. You remember what was Planck's theory? Planck's quantum theory. He was doing some maths. E is equal to h nu. बस यही याद है. Actually, Planck's theory said that a lot of quantities, almost all the quantities in the universe, they exist in the form of packets, right? Okay, like mass, energy, charge, a lot of other things. So for light, the Planck's quantum theory says that energy is not radiated continuously, it's radiated in small packets, okay, small tiny packets of energy called photons, right, called photons. So basically it's the photons, what Bohr applied of this theory, how Bohr used this theory is this, that he said that since the energy is not radiated continuously, only packets are radiated, so it is that the electron should never move out of its orbit, should never move in continuously decreasing orbit, because in that case the energy radiated would be continuous. Getting the idea? Remember what the drawback of Rutherford model was that because of radiation, EM wave radiation, the size of orbit was decreasing, and all this duration, what was happening? EM waves of different frequencies were continuously emitted, right? Which contradicts Planck's theory, right? So what Bohr said that, this, no, this cannot happen. He said, no, this cannot happen. Energy cannot be radiated continuously. It can be radiated only in small packets. Okay? So which means this kind of effect would not happen. So basically the classical electromagnetic theory, this Maxwell theory was called classical electromagnetic theory, would not apply to atomic size, okay, to atomic dimensions. Okay, energy cannot be radiated continuously. Okay, so that was the first thing he said. Okay, he had no proof of it, he just hypothesized. Okay, he just gave a theory of this. So what he said, his first postulate, first of all I'll tell you, this is valid only for hydrogen or hydrogenic atoms or ions. So it is valid for H, He plus, Li2 plus, and so on. So I would be calculating this for any hydrogenic atom having Z atomic number. Okay, directly doing that so that we can use it for hydrogen later on, putting Z is equal to 1. So what was his first model or postulate? His first postulate was that electrons revolve around nucleus in stable orbits under influence of electrostatic force attraction. Since energy is not emitted continuously, since energy is not emitted continuously, the orbits the energy of electrons in these orbits is stationary, is constant. Okay, since energy is not radiated continuously, okay, the energy of electrons in these orbits is constant or stationary, and that's why these orbits are called stationary states of an atom. It was this assumption of Bohr, of stationary states of an atom, which led to success of his model, this assumption. So from here we can pick one thing, that let's say this is nucleus. If Z is atomic mass, the nucleus would have a charge of plus Ze. If Z atomic number, if Z is atomic number, Z is the number of protons basically. If Z is the number of protons or atomic number, the nucleus would have a charge of plus Ze, while the electron would have a charge E. So can I attend the Maxwell theory lecture in the first place? I explained that clearly. So let's try to understand what Maxwell said. Maxwell said that if you remember, when we were doing electromagnetic waves, we studied that whenever there is changing electric field, there is changing magnetic field, okay, and the changing magnetic field in turn produces a changing electric field. Okay, two laws were working in tandem, which means in synchronized manner. Changing electric field produces changing magnetic field, which was given by Maxwell Ampere's circuital law, right? Okay. Now changing magnetic field produces induced EMF, which was given by Faraday's law, and induced EMF gives you electric field, changing electric field. So they are clubbed. The change must not be, continuous change. That if electric field is proportional to time, obviously its derivative would be constant. We cannot do anything. It should be continuously varying with different values, not linearly, right? So basically we studied this at that point of time. If change happens in one type of field, that change is it happens in the other type of field, then in the first type, then in the second type, so on. This change in electric field is radiated, communicated to all the charges in the universe in the form of electromagnetic waves. So electromagnetic waves are nothing but bundles of changing electric and magnetic field, right? Okay. So what causes change in electric field? What causes change in electric field? A moving charge, a charge moving with constant velocity cannot produce changing electric field. It can produce a linearly changing electric field, which is useless to us. It won't produce a changing magnetic field if we differentiate it, right? So it's like if an accelerated charge is there, then it produces a changing electric field, which produces changing magnetic field and so on, which means an EM wave. Since the EM waves have some energy, so some of the energy of a charge is carried away in EM waves. So I summarize what I said. I said that whenever a charge accelerates, it radiates electromagnetic waves, okay, and these electromagnetic waves carry some energy of the charge, okay, into the space. That's what I said, and that's what we applied here into the Rutherford model, right? I hope it's okay now. So can we continue now? This was the first postulate. Please side, we are not able to note it, so note it now. I have taken a side now. So let's start with the second. The second postulate was, we studied the concept that only stable orbits exist. But what are these stable orbits? What properties do they have? What properties do they have? This was explained by second postulate. Only those orbits exist in which the angular momentum of an electron is an integral multiple of h upon 2 pi, right? So basically mvn Rn is equal to nh upon 2 pi. What Vn and Rn means? Velocity is nth, velocity of electron in nth orbit. Rn is radius of nth orbit, right? So it is n times the integral multiple, right? So first orbit would have h upon 2 pi as angular momentum, second one would have 2h upon 2 pi, 3h upon 2 pi, and so on, right? So this was the second. Now let's discuss the third postulate. Okay. The third one was that, you know, uh, since he earlier said in the first one, in the first postulate, that electron cannot radiate energy continuously. Electron cannot radiate energy continuously. What happens actually? Energy is radiated in small packets. Whenever energy is radiated in small packet, the electron jumps from higher energy to lower and vice versa. Okay? Or I may say that whenever an electron absorbs energy, it jumps to higher energy state. Okay? And whenever it releases energy, it jumps from higher energy state to lower. But not all not all possible photons are absorbed. Only those photons are absorbed